Hey everyone, and how goes it? Welcome back to Computer Science 145. Today, we're going to talk about branching statements. Flow control is the order in which a program performs its actions. There are two types of flow control elements, one called a branching statement and another one called loop statements. A branching statement chooses between two or more possible actions, while a loop repeats an action until a stopping condition occurs. As programmers, there's a couple of pieces of advice that I can give to anyone, and one that I use often is when in doubt, draw it out. One way we could do this is using what's called a flow chart. These diagram the flow of a program, and the way that you can think about this are boxes are the statements where diamonds are decisions which have a true and a false branch. Arrows indicate the flow of the statements and their decisions, and pseudocode is mostly used. Now, the essential element of a branching statement is called the if statement. Now, if the Boolean expression inside the argument of the if statement is true, then the body of the if statement is executed, but otherwise it's ignored. We can see over here, this is the syntax of an if statement. And remember, whenever we saw anything inside of parenthesis, this counts as an argument. What an if statement expects is what's called a Boolean expression. We're going to go into more detail about these later, but essentially a Boolean expression is an expression that yields true or false. So if this is true, then these statements inside the body, in other words, inside the curly braces of the if statement, are run. Putting curly braces denotes the body of the if statement, and I strongly encourage that you use these when you're writing them. Also, you'll notice there is no semicolon after this if statement. If you were to do this, it will not logically work. So don't put a semicolon at the end of these if statements. Now, as we are developing our programmer voice, and what we're doing is communicating with the machine in order to solve a problem, you can think about this as though you're speaking to it saying, if this is true, then do this. So for example, if A is equal to B, then we system.printout A is equal to B. Now, in relation to the flowcharts, the way that we can look at this is here is our if statement, and here's a general if statement flowchart. What we have inside this diamond, the decision, is the Boolean expression. If this evaluates to being true, then we run the body of the if. However, if this is evaluated to being false, then we skip it and continue on. Drawing out the logic can help understand what's going on, especially if you're dealing with some kind of logic error. Another part of an if statement is called the else statement. Now, this requires a preceding if statement. So in other words, you cannot write an else without an if. Now, the way this works is if the Boolean expression, the argument of the if statement, is false, then the body of the if is ignored and the else is run. Once again, putting curly braces to denote the body of the else statement is strongly encouraged. And the way that you would speak this is, if this is true, then do this, otherwise, or else, do that. Now, the else is in addition to the if statement. You can have standalone if statements without an else, but an else requires an if. Now, the example of this would be, once again, if A is equal to B, then we'll print out A is equal to B. But if this is false, then we skip over this and run what's inside the else, which is A is not equal to B. Now, in order to diagram this, you can see this looks very similar to what was presented before. So in other words, if this Boolean expression, if this decision is true, then we run the body of the if, and we skip the else part. However, if this Boolean expression evaluates to be false, then we skip the if part and only run the body of the else. Branching statements provide decision-making within our code. Now, we've been talking about this thing called a Boolean expression, which is required as the argument of the if part. But what are these? Well, Boolean expressions are fairly straightforward. They're either true or false. Now, just like the math that we have described before, we have certain operators that we use to evaluate whether or not something is true or false. Some of the most common ones that you'll see are the two equals side by side. This corresponds to equal to. The exclamation point equals indicates not equal. Also, we have strictly less than, strictly greater than, less than or equal to, which is denoted by a less than followed immediately by an equal sign, and also greater than or equal to, which is basically the same thing. So whenever you're writing a Boolean expression, you have a value over here, some sort of operator, and then another value. This entire expression will evaluate to either true or false. So we can see over here, we've already declared this variable, Boolean a, and remember, Boolean is either true or false. And then what we're doing is evaluating 12 is greater than 3. As we know, 12 is greater than 3, so a would be assigned true. As this was assigned true, if true, then we print this and ignore this. Now, as the variable a is a Boolean, we can simply use that inside the arguments of an if statement. However, if we wanted to be very sure, what we could do is evaluate if a is equal to the value true. Both of these would do the same thing. Now, in order to make these more advanced, you can also have what's called compound Boolean expressions. And what this does is it combines multiple Boolean expressions together. So the common compound Boolean expression operators are two ampersands side by side, and this corresponds to and. In order for the compound Boolean expression to be true, both expressions must yield true. Now, alternatively, the two bars side by side is the or, and this means only one must be true in order for the entire expression to yield true. Now, in the past, I've gotten a lot of questions about where you find this symbol. On most standard keyboards, it is the key that is above the Enter key. And usually you have to hit Shift and that key. So the syntax for a compound Boolean expression would be you would have one Boolean expression over here, this operator, and then another Boolean expression. We can see an example here where once again we have declared this Boolean variable a, and we are assigning it to 2 is not equal to 0. This is true. And 12 is greater than 3. We also know this is true. Since this is true and this is true, then a is equal to true, and so this would run. To better understand compound Boolean expressions, we often look at what's called a truth table. Now imagine that we have two variables, a and b. So for all the combinations of a and b, if a and b are both true, then that is true. And also, a or b is true, then the compound Boolean expression will be true. Now once again, for the and, both have to be true in order for the entire compound Boolean expression to be true. So for instance, if a is true but b is false, then the entire expression a and b would be false. However, a or b, with the or operator, only one element needs to be true for the entire expression to be true. So because a is true but b is false, a or b still evaluates to being true. Now in reverse, if a is false but b is true, then a and b would still be false. However, a or b would be true. Now if both a and b are false, of course a and b is going to be false. But also a or b would be false too. You can think of the and operator as being the opposite of the or. Now, speaking of that, the exclamation point is used to negate the value of a Boolean expression. So as we can see in this table, we have a negated expression and the equivalent expression to the side. So if we not A is less than B, then the equivalent expression would be A is greater than or equal to B. It would not just be strictly greater than, the equal to element must be included. Now similarly, if A was less than or equal to B and we negated it, then A must be strictly greater than B. And the same thing for strictly greater than and also greater than or equal to. Now, if we were evaluating A is equal to B and negated that, then it would simply be A is not equal to B. And also the same thing in reverse. Now, as mentioned before, whenever you negate an and, it becomes an or. And similarly, when you negate an or, it becomes an and. Understanding how this works will help us avoid these types of logic errors. Now let's see how we can start including decision making within our programs. So the problem that we're about to solve is, let's say that every morning I like to wake up, and I like to wake my brain up by having a math challenge. Math is amazing, so why not start a day with a good math problem? So as we can see over here, we've already set up the project, and what we're about to do is go ahead and create the class. We're going to right click, go to new, and create a new class, and we're just going to call it Math Challenge. And also we're going to include the entry point, in other words the main method, and then we're going to click Finish. I'm going to go ahead and clean this code up a little bit by taking out that comment. And also, I'm going to make sure to put a comment at the beginning of my code, which is my name. Written by J.J. Shepard. Now let's say we're going to keep this fairly simple. Let's say that the math challenge is just going to give me a simple addition problem to wake my brain up. Well, this inherently means that this program is going to need some kind of input, and as we know, we're going to use import java.util.scanner in order to use the type scanner to gain input from our console. Now, immediately inside the body of our main method, we're going to go ahead and tie together the scanner with the standard system input by scanner keyboard equals new scanner system.in. And now we can use the scanner, which we have called keyboard, in order to access elements from the console. The next thing I'm going to do is prompt the user. So I'm going to use the standard system output to print something to our console. System.out.println, print line. Now inside this argument, I'm going to put the string as denoted by the double quotes, and I'm just going to say, are you ready for a math challenge? Now I'm asking a true or false question, so I'm also going to include to the user what they need to do next. To format this nicely, I want this to jump down to a new line. And instead of writing a separate system.out.println, what I can do is use the escape character /n, which will jump down to the next line. Now immediately after that, I'm going to say enter true or false. Now maybe I want to format this a little better as well. Maybe what I want to tell the user is enter literally true or false. And we could use the double quotes to do this. However, notice this. If I were just to put a double quote in there, I'm going to end up with a syntax error, because this double quote and this double quote indicates this is the start of the string and the end of the string. I don't want to use this type of double quote. I want it to be literally in this string. Now, just like the escape character /n adds a new line, I could put a slash in front of this double quote, which means the literal quote, and not the programmatic one. So I can do it like this, and I could add the double quote to this. Now, if I'm going to go ahead and run this just to see how this works, you can see how this string is going to be formatted. Where that /n is, it skipped down to the next line. And also, where I put the slash quote, it put the literal quotes around this. It's just a nice way to format strings. Now, as I have asked the user, true or false, do you want to play this? I need to be able to store that information. What I'm going to do is create a variable which needs to store a true or false value. The type that I know that stores only true and false values is called Boolean. And I'm going to call this variable play. Then I'm going to assign this to keyboard.nextBoolean. Now, much like nextInt and nextDouble, nextBoolean captures the first Boolean or first true or false element that's entered into our console. Now we get to some decisions. If. Now inside this argument, we have to put in a Boolean expression. So what I'm going to simply put is if play. If the user says true, then the body of this if statement in between these curly braces is going to be run. And so I'll simply prompt the user system.out.println, let the challenge begin. However, if the user enters false, then we need an else. So if play was false, then we're going to do system.out.println aw. And after that, we kind of need to immediately stop the program. The way that we can do this is by using this command, system.exit. And we'll just put in 0. Now, just to put a comment here, this immediately stops the program. So whenever you need to halt the program, you can use this command system.exit to stop it. Now, we haven't gotten to the math challenge yet, but let's test this out and see if it works. Running this. Enter true or false. I'll enter true. And sure enough, this command was run and the body of this was ignored. Now, doing it the other way, if I enter false, then it prints out aw and immediately stops. Now that we know this is working, let's go ahead and present our math challenge. And let's keep it simple at first. Let's just do simple integer addition. I'm going to define int num1, and let's just assign it to the value 2. And let's also do int num2, assign it to the value of 3. After that, let's evaluate this and store it into int result is equal to num1 plus num2. We've both declared and assigned the values 2 and 3 respectively. Then we evaluate 2 plus 3, which the result is 5. Now we prompt the user again. System.out.println. What is... Now we're just going to append num1 plus that plus num2 plus, and let's just put a question mark. Now we could have literally put in the values 2 and 3 into this string, but we kept this open-ended because you can change these values however you see fit. So if we wanted to change these up, then it's still being reflected here. Now since we asked the user this question, we now expect the answer. So let's store that into int answer is assigned to keyboard.nextInt. Once we have that value, let's decide whether or not it was correct. So if answer is equal to our result. So if the value entered here is the same value that we calculated up here, then the body of this if is going to run, and we'll just simply say system.out.println, you win. But if they entered an incorrect answer, then we need to tell them system.out.println, sorry, nope. And now we have a simple math challenge program. Let's see it in action. Compiling and running this. Am I ready for a math challenge? True. All right, what is 2 plus 3? That should be 5. And sure enough, since this was equal to this, it prints out you win and ignores this. Now let's see an alternate version. Once again, I'm going to enter true. 2 plus 3, let's say I enter the wrong answer like 6. Because this was not equal to that, it skips this and only runs this. Now let's see one more variation. If I were to run this and I initially say false, it immediately stops the program right here and ignores the rest of this. So going into a little more detail, we can use the double equals, and it's great for determining if two values are equal in some cases, but not every case. It's absolutely great to use when we're comparing integer values, but it may not be so great when we're comparing floating point values like a double. As mentioned in a previous lecture, we know that floating point values or doubles are close approximations, but they're not exact. So the example we used before is 1/3 is not quite 1/3, because as we know 1/3 is 0.3 repeating until infinity. But we don't have infinite amount of storage, so it's a close approximation to 1/3. It's always a good idea for whenever you're using double values to use a combination of greater than or equal or less than or equal to with some sort of tolerance. In other words, a plus or minus value. So if it's close enough to the value, then we consider that value to be equal. Also, using double equals is absolutely great when we're comparing memory addresses of objects. As we have mentioned before, when it comes to a class type that creates an object, the object is always separated by a memory address reference, and that reference refers to the contents of the object, like a string. So for instance, if an object is null, so in other words, it does not exist in memory, then we can use double equals. We can also use double equals to check if two different identifiers refer to the same place in memory, and this becomes important a little later on. However, using double equals is not great for comparing the contents of an object. It is better to use an object's method like dot equals to evaluate this. This absolutely applies to how we use strings. You should not use double equals with strings, because you may end up with certain kinds of logic errors. Now let's see an alternate example of the program that we just wrote that utilizes a string. Now we're going to keep this mostly the same, but we're going to edit it slightly. So first of all, are you ready for a math challenge? Enter true or false. Let's change this. Instead of true or false, let's say yes or no. We could assume true and false whenever we were looking for a Boolean, but now we have to convert this over to a string. Now, as you notice here, this gives us a syntax error because we can't assign the value of a Boolean to a string. We need to use a different method from our keyboard. We're going to call keyboard dot next line in order to capture an entire string from our console. And now you'll notice over here, there's a syntax error because strings do not evaluate to true or false. But what we can do is use a method that returns a true or false value. So we can use play dot equals, and we could say the string yes. Now there's no syntax error because the dot equals method, as we can see, returns a Boolean value. What is expected in the arguments of an if statement is that Boolean value. So if the user enters yes, then we can run the program. Now let's see this in action. Compiling and running it, I can enter the value yes, and sure enough, it continues. Running the alternate version, I can enter no, and it stops. Now running this one more time, I'm going to try this. All capital yes. Oh, but wait a second. It ended the program. Well, that's not what I wanted. I mean, I still said yes, but I used all caps. So why did it end the program? Whenever we use the method dot equals, it's looking for the literal version of what's inside of here. So in other words, if this is all lowercase, then we must put all lowercase inside of here. Now, I think this feels a little absurd, so what I want to do is maybe use an alternate version of dot equals, and this version can be called dot equals ignore case. And so, now it doesn't matter how you enter yes, it'll just run. Let's see it. So, am I ready for a math challenge? Yes. And sure enough, it works. Now, let's further augment this program, because I feel that directly assigning these values here really doesn't pose much of a math challenge at all. So what if I wanted these values to be randomly assigned? Well, if I look through the Java documentation, I can discover that there is another class type that I can use to create a random number generator. Now, much like scanner, up here, what I'm going to do is import java.util.random. Now, this includes the type random, much like this included the type scanner, which we use here. Now, after we have constructed our scanner keyboard, below that, I'm going to create a random R and assign that to new random. Random is a class type. We use this identifier R and then construct this inside of memory to create our random number generator. Now what I can do is scroll down to where I have this number 1 and number 2, and I can call r and then the method .nextInt. And the same thing right here. Now, what these methods will do is randomly select some integer value. And if you're using a fully functional IDE, one thing that you can do is hover over top of these methods to see what they do. So let's read through this. So first of all, we can see it returns an int, as you can see right beside that green dot. Now reading this method's description, this returns the next pseudo-random uniformly distributed int value from this random number generator sequence. The general contract of nextInt is that one int value is pseudo-randomly generated and returned all 2 to the power of 32 possible int values that are produced with approximately equal probability? Ooh. I don't know if I really want to have all 2 to the power of 32 possible int values. Maybe I just want to keep this simple and have this range from, 0 to 99. So in other words, 100 possible values. If I'm always considering this to be only 100 possible values, then that feels like a constant. In order to augment this, I'm going to go outside of the main method and define this constant. Public static final int, and I'm going to call it RNG range and define that as 100. Now, because I've read through the documentation and I understand the methods inside this random number generator, I know that I can pass an argument inside of these method calls. So watch this. RNG range, and I'm going to do the same here. RNG range. Now, if I hover over this method, it changes it. This returns a pseudo-random uniformly distributed integer value between 0 inclusive, meaning it includes 0, and the specified value exclusive. So this means it does not include the number 100. Thus, this will pick a number from 0 to 99. Understanding the difference between inclusive and exclusive operators and values can help avoid logic errors. Now, let's see how this is going to work. Running this. Am I ready for a math challenge? I'm going to enter yes. 85 plus 23. And as we know, that is 108, and we win. Let's try it again. Ready for a math challenge? Yes. Wow, that's easy. 10 plus 6, well, that's 16. And we win again. And now this feels a little more challenging as we've added in this random element. But maybe addition isn't the most challenging thing in the world. Let's alter this just slightly again to make this very challenging. Instead of addition, we're going to change this to this number to the power of that number. Now, in order to indicate this, inside of our system.out println, I'm going to use the caret, as you may have seen in several scientific or graphing calculators. But also, let me point this out. If we were to change the plus sign to the caret, now see, the thing is, this caret operator does not raise this to a power. It's a completely different style of operator, which is exclusive OR. In order to raise this to a power, what we need to do instead is utilize something that is built into Java. Whenever we need to do these kinds of mathematical functions, we should rely on math. Now, math is an object which has several methods. For instance, if we press dot, we can see that there's a method called pow. math.power. Now the arguments that it expects is the base value and its exponent, which we'll just fill in as num1 and num2. And now we can get rid of those values here. However, as we can see, there's a syntax error. And if we take a look at what the power method returns, this entire thing becomes a type double. As we remember, doubles are 8 bytes in memory. An integer is only 4 bytes in memory. We can't store this value inside of this container. But what we can do is typecast it. So in front of this, I'm going to put parenthesis int, which now typecasts this double after it's evaluated to an int and stores it right here. However, there is another small error that we need to take into account. Before, we had this random range going from 0 to 99. The problem with this is we could accidentally choose a number that's outside the scope of an integer. In other words, what if the two numbers that were randomly selected were 99 and 99? This would evaluate 99 to the power of 99. That's a huge number. I don't really want to deal with that. So why don't we just reduce the random range? Let's say instead of 100, we just do it from, let's say, 10. And now this value will go from 0 to 9, and this one will also pick a value 0 to 9, which seems more reasonable. By the way, notice what I just did. Originally, as we can see again, this was the value of 100. By taking out this 0, it now becomes 10. However, in our program, this is reflected here and here. I didn't have to change any of this code. I just changed one part up here. This is why we want to use constant values instead of magic numbers. If I had put 100 here and 100 here, just the values 100 and 100, I would have to change the program in two separate places. If we rely on using constants, we only change it in one place, and that change is reflected throughout the rest of the program without any other code alterations. Now, let's save this and see what happens. Ready for a math challenge? Yes? 9 to the power of 0? Well, that's 1. And we win. We've explored basic computation, and now we've added decision-making into our programs. This is vital for checking different types of errors and other types of functionality when we need to make decisions as to what statements to run and what statements to ignore. With all that being said, I'll see you next time.